If you're a network administrator in a virtualized data center environment, you're most likely going to want to have visibility right down to your individual VMs. Well, that's going to be the subject of this particular nugget as we examine Cisco's virtual machine fabric extender or FEX technology. We'll also review for you in this important nugget the amazing Cisco Nexus 1000V switch. My, how times have changed, haven't they? Our world used to look like this. We would have this server system. This server would have a network interface card, and this server would provide the basis for an operating system and an application running on that operating system. Maybe this was our World Wide Web server, and maybe it was Microsoft Windows Server 2000 running on that particular device, and it was Internet Information Server focusing or providing us with web services. So, one of the things that happened out of this was this clear demarcation between our server folks in the IT department and our network folks in the IT department. We had a network person that would be responsible for this switch that would provide connectivity to the network interface card. This network operator would assign the appropriate VLAN and the appropriate policies to that one port that would coordinate with that one NIC, with that one OS, with that one application. As you know, things have changed dramatically in the virtualized world. And what starts happening is that server person started to have to take on more and more responsibilities of the network person. And that's because of virtualized switches that exist in a VMware environment. Virtualized switching is a great concept, but it pushes more and more of these network tasks into the server responsibilities. And that's where Cisco really started to shine when it released the 1000V. And we'll talk about that a bit more. But let's back up for a moment before we get too deep into this, and let's just really make sure you're aware of the initial VMware vSwitch approach to switching in a virtualized world. So, what I would refer to as kind of first generation technology when it comes to virtualized switching would be the classic vSwitch from VMware. So, notice what's happening here. We have our bare metal host, and here are VMs. We can see those always represented as simple squares in this type of a diagram, and we can see that the VMs are accessing the virtual switch. Yeah, through what we call a VM virtual NIC. And the virtual switch is going to go ahead and move the traffic down through the host to our network adapter that's in the host. These now become trunk links, don't they? And they trunk to access layer switches that we might have in our infrastructure. We might trunk directly to what we would consider a distribution layer, but you get the point. Access layer intelligence has extended down into the server person's realm, right? That server slash VMware person in our environment is now dealing with switching, particularly those virtual switch. These virtual switches, they are indeed like physical switches. They maintain a table of the connected devices, and they forward frames based on this particular table. Now notice, obviously, upstream, they can be connected to their VM NIC, and the problem with these V switches that VMware ran into was they didn't offer the robust advanced features that we might find with Cisco switches. So they were very, very basic in their operation. Something else with these virtual switches that quickly became a cumbersome limitation is that you can see they are a one-to-one relationship with their host. Specifically, the virtual switch could not span a particular host system. You might have more than one virtual switch on a host, so I guess it's not a true one-to-one relationship, but you get my idea. You get the concept here, right? The virtual switch cannot span beyond that particular host system. So here's a real typical illustration that I have for you of our three virtual switch, and those three virtual switches are dealing with three separate hosts. Another concept that I want you to be aware of is a port group. And this port group terminology, this port group technology was invented by VMware. And this is how we can take a subset of our ports on one of these V switches and assign certain VM connectivity. So we can group VMs into port groups utilizing these V switches. So this is, again, what I kind of call first generation technology when it comes to virtual switching. This is the classic, if you will, virtual switch from VMware. Let's take a look at their second generation invention. So it was about VMware vSphere 4. Yeah, we're at 5.5 as I record this particular nugget, but back around vSphere 4, VMware introduced the vNetwork Distributed Switch, or VDS as we know it. That's lowercase v, uppercase D, uppercase S. This is what they call a DVS, a Distributed Virtual Switch. Notice that now the virtual distributed switch can span hosts. So it is providing the network connectivity for these VMs that live on different hosts. This particular virtual distributed switch was revolutionary for VMware and also finally added robust capabilities that network administrators that had used Cisco products were used to having. Things like private VLANs, inbound rate limiting, and tracking VM port states utilizing migration capabilities. This distributed virtual switch ended up being very important for robust vMotion capabilities inside of VMware, where we would want to move VMs easily from one host to another host for various reasons. So this was our second generation of technology, the virtual distributed switch. Keep in mind that this technology does not eliminate a standard vSwitch, and that plenty of VMware implementations out there offer the situation of the standard vSwitch being used still for certain purposes, and then the virtual distributed switch being used in the VMware environment as well. Well, it's time for us to discuss the third generation of technology when it comes to this topic, and that is, drum roll please, gosh, I've got to find that drum roll sound effect for my nuggets. Anyways, it's the Nexus 1000V switch. This will be a bit of review for you since you are coming from my CCNA data center training, but let's just quickly review the 1000V. So Cisco and VMware teamed up, and guess what? They created a replacement technology for the virtual distributed switch. It's the Nexus 1000V. And when we connect to this Nexus 1000V at a command line, let's say, we're going to feel like we're at the Nexus OS. We are at the Nexus OS. So this is going to be a great marriage of technologies, isn't it? We can even connect to manage this thing through a rack mount appliance. So Cisco even sells a rack mount box that you would use in order to connect and manage the 1000V. The 1000V functionality is split into two components that I want you to know. There's a virtual supervisor module. Okay, this is our control plane component. And then there's the part that it manages that everybody's connecting to, and that's called a virtual Ethernet module. So the virtual Ethernet module is actually switching the data traffic and runs on a host, on a VMware host. This virtual supervisor module can end up controlling several virtual Ethernet modules, and those virtual Ethernet modules are all functioning within the VMware vCenter environment. So, a remarkable combination of technologies here from Cisco and VMware to bring networking with a whole host of functionality to the equation for us. We can do layer 2 private VLANs, we can do port channeling, IGMP snooping, QoS, access control lists at layer 2, access control lists at a layer 3 environment, port ACLs we call them, IP source guard, dynamic address resolution protocol. The list goes on and on and on of functionality that exists because we are bringing Nexus operating system intelligence to this entire equation. Now, as I said, you're going to feel very comfortable working in the 1000V because you'll be at a command line. Yeah, it'll be like VSM -1 and then config in parentheses to know you're in global configuration mode. Now, one of the configurations that you're going to make is the creation of a port profile. This is our concept inside the 1000V that coordinates to those port groups that we mentioned inside of VMware. So we have our port groups in VMware, and we're going to create port profiles in the 1000V to coordinate with those. So what would be in one of these port profiles? Well, like switch port mode access. That important command that sets a port to access mode. How about the VLAN assignment? Yeah, that would be switch port access VLAN 102, for instance. We can set the VMware port group name. By default, we typically would just set it the same, right? And that would be done with the command VMware port group. You end up no shutting this thing, and then you enable its state. And this is syntax that you would use, that state enabled. This is syntax that you would use, again, on your Nexus 1000V. The port group that VMware utilizes, that concept would automatically be created for use in the VMware environment. Too cool, this simple integration between the Cisco Nexus world and the VMware world. Now you might ask how the switching actually works. Let's say we have this virtual Ethernet module here, and we have one here. We know these virtual Ethernet modules are managed by a virtual supervisor module. Now, what happens is for VMs that are part of the same VM, they can communicate with each other all they want, and that switching intelligence is handled by the virtual Ethernet module. Now, let's say we have a couple other VMs on the other virtual Ethernet module. If they want to communicate with the other virtual Ethernet module in this environment, that's when forwarding down to a maybe traditional network takes place. And that traditional switch can allow the virtual machines that are on different virtual Ethernet modules to communicate. So now that we've toured the generations of technologies that exist with our virtual switching, right? We had the original virtual switch, we had the distributed virtual switch, the 1000V. Now let's turn to this topic of FEX itself. What's this about? Well, it's about easier management. In traditional networking environments, we had a distribution layer switch, let's say, and we would go in and configure that, blah, 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 all this configuration. And then that would connect to an access layer switch, and we would go in there, blah, 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 all that configuration. FEX, the very basis for this concept is less configuration, reducing the layers, reducing the complexity of configuration. So from my earlier videos in this course, and most particularly in the CCNA data center videos that you've watched here, you know there's something like the Nexus 5K, and that this Nexus 5K can communicate with a Nexus 2000 FEX, we call it. The Nexus 2000 FEX. You remember these devices have a parent-child relationship. So we go and we make configurations here, and those configurations carry down to the child device. Really what's happening here is that child device is acting like a line card connected inside the 5K. At its heart, that's what we're talking about with FEX technology, right? Reducing the management that we have to do from the old world to the new world. Now, do you remember what the technology Cisco invented for this to work, for these two to communicate, and for the 5K to know about a port on that 2K that it's responsible for? That technology was called VN tag technology. So thanks to VN tagging, this parent switch can configure and manage interfaces on the child switch. So what an important moment here, taking a look at this FEX technology. But wait a minute. This isn't really FEX yet. No, because in fact, really what I've drawn here is technically Cisco fabric extension, Cisco FEX, because we have not drawn in here the VM. Yeah, we haven't drawn in the virtual machine. Okay, what if we could have a technology that goes from here down into our host with its virtual machines? And what if we could literally have these virtual interface cards understand and engage in this VN tagging behavior so that we could extend right down to the blade this visibility of the VMs? Well, that is exactly what we get with what we term Cisco FEX. And notice what's remarkable about this is it doesn't have to involve that fancy 1000V. Yeah, we can eliminate that layer of complexity of either Cisco's distributed switch or VMware's distributed switch. Yeah, it's amazing. What this really comes down to is the evolution that we've had in network cards. Yeah, we have a card that we've spoken about, the virtual interface card. Yeah, the Cisco VIC. And this Cisco VIC really makes the magic happen. The VN tag can be used between the dynamic virtual NIC and the fabric interconnect, and then this information can be communicated upstream to our upstream devices. Remarkable the advancements that have been happening rapidly in these particular technologies. So I guess it's fair enough for us to say that there's really 4 generations of technologies here, right? There's the virtual switch that was our first generation technique. That was VMware only. There was the distributed virtual switch, and this was the VMware only thing. It was an improvement on first generation. Then we had our Nexus 1000V come along, a collaboration between Cisco and VMware. And then our fourth generation is what we are discussing now, and that's Cisco VM Fabric Extension. These technologies can end up working with each other. They are not mutually exclusive. And I think that's one of the reasons that students have such difficulty with these discussions. Understand that we can do Cisco's VM FEX now without the 1000V as an example, but the 1000V could be used in a Cisco VM FEX environment. So thus the confusion. Let me further elaborate on this Cisco VM FEX. So we have our VM connecting utilizing a VM virtual NIC to a virtual Ethernet module. It does not have to be of the 1000V. Okay, yeah, it's just called a Cisco VEM that we can have in our VMware environment. So it connects into the Cisco virtual Ethernet module. Then we have the Cisco VIC network card on our host that can go ahead and make a connection directly to the Fabric Interconnect. How exciting. This is called a virtual Ethernet port at that point on the Fabric Interconnect. How can we make these configurations? Well, once again, we use in the UCS manager this time, we use port profiles. Yeah. And the UCS manager port profiles are going to create the appropriate port groups in the VM environment, specifically the VMware environment. Remember, we had that earlier discussion where the Nexus would use port profiles, and this would create the appropriate port groups in the VMware environment. This time, it's the UCS manager creating the port profiles for our port groups, because again, we can do this without leveraging the 1000V technology. Now, you know what one of the tremendous benefits of this Cisco VM FEX technology? Well, one of the biggest benefits is indeed performance. You know why? The Fabric Interconnect is moving all the VM to VM traffic. It's doing it all in hardware. Yeah, the Fabric Interconnect is moving the traffic from VM to VM. It's doing so in its hardware, and we know this is a kind of universal computing concept, right? That hardware always outperforms software. When it comes to moving traffic, doing things in the network, the hardware solution is always superior in performance. So we got to love it. The Fabric Interconnect possessing specialized hardware to do the forwarding of VM to VM traffic for us. So I know for many of you, this is an absolutely brand new concept. I mean, you maybe were familiar with the 1000V, and now we start talking about capabilities that move beyond that. So I just wanted to really emphasize this new Cisco VM FEX technology in this important nugget today. Here's the ingredients, by the way. On the Cisco UCS manager, we would of course create a connection over to the vCenter server. We then, on the UCS manager, create our distributed virtual switch. We might even be creating multiple ones of those. And then on the UCS manager, we create those port profiles. Those distributed switches we created in those port profiles are pushed over to our vCenter server. Now we have our distributed virtual switch, and over here we have our port groups for assignment in our vCenter server product. In vCenter, we're going to create our VMs, and those VMs are going to be linked to these port groups. Then we're going to create our VM's virtual NIC. As you know, on the Fabric interconnect, we're going to create our virtual Ethernet connection, and we have built the infrastructure that's going to be utilized in order to have these VMs actually hosted on blades in our environment communicate with each other very, very efficiently and quickly. Notice what's fascinating about this is that the UCS manager is really driving all of this required configuration. So we can leverage our knowledge of UCS here and leverage the very powerful UCS manager interface for driving the data center's configuration, including the great performance we're going to get in the data center. Remember, when we create these port profiles, we're doing things like setting the VLAN, the native VLAN. We can go ahead and do our QoS here. We can do our security configurations here. So the port profile creation becomes a key element in this overall configuration of Cisco's VM FEX. Now, this is going to shock you, I think. There's starting to become generations of Cisco VM FEX. Yeah, what we've been talking about thus far is called standard. It is also often referred to as pass-through switch mode, or PTS. There is another option now, and it's called universal pass-through by Cisco. Sometimes you'll see in the VMware literature, it's called direct path IO with vMotion. These two technologies can coexist, but let me just explain to you that in universal pass-through mode, the VM traffic is processed in hardware, and then it immediately after it originates on the VM, the traffic is sent directly to the Cisco VIC. It's then tagged with its VN tag, and it's sent to the Fabric interconnect for network configuration and layer 2 forwarding. This is the ultimate in performance because absolutely everything is done in hardware. Yeah, in the standard pass-through switch methodology that we described, yeah, it's almost strictly hardware-based forwarding. Okay, it's almost. If you remember, there was that virtual Ethernet module that we were describing, and it was getting involved in the process, and there was a wee little bit of software going on there. What we're talking about here is a bypass of the hypervisor that VMware utilizes. By the way, some more history on this for you. Notice how this is called direct path IO with vMotion. Yeah, there was a direct path IO approach used, but unfortunately, you couldn't use vMotion with that technology. So now universal pass-through is called by VMware direct path IO with vMotion. Now, you look at this universal pass-through approach of Cisco VM FEX and you say, give it to me. Yeah, you say, I want that unbelievable performance associated with that. Well, just be aware that as of the time of this recording, there are going to be VM guest OS restrictions. Yeah, for example, Windows 2008 Service Pack 2, Windows 2008 Release Candidate 2, Red Hat Linux 6.0. Yeah, all kinds of restrictions. SUSE, Linux Enterprise Server, would be at 11 or 11 Service Pack 1. So there are going to be restrictions there. The VM virtual NIC technology that we are utilizing must be of a type VMXNet 3. And your guest operating system has to be running the supported universal pass-through VMXNet 3 driver. The VMs themselves, the memory that they are calling upon, that memory must be of a type reserved in the VMware system. So to get this incredible performance that universal pass-through Cisco VM FEX provides, we are going to have to watch out for potential limitations. So what's it like to go ahead and install Cisco's VM FEX solution? Well, you first start by installing the VM FEX virtual Ethernet module on the particular host where you want to run this technology. There's an offline method you can do it that's manual, or the much preferred, more often seen online method. The online starts from VMware vSphere. Yeah, you go into the update manager on your vCenter server. After you've installed that update manager, you check the VM vCenter update manager configuration to ensure the correct URL is specified for downloading your necessary patches. Usually, we do a custom update which points to VMware's site. With the custom update, all required third-party patches are downloaded from VMware. Now notice you could specify another option by manually adding a download source, and you would put in your Cisco UCS manager's URL to pull the required software down from Cisco UCS. So when you do the update manager for your VEM, your virtual Ethernet module installation, there are two instances in which the VM gets installed. When the VMware vCenter Update Manager administrator executes the add a new download source procedure, or when an ESXi host is added to the distributed virtual switch. Now your next step in the process is to configure the integration between UCS Manager and VMware. The easiest way to do this is to slide over to the VM tab in your Unified Computing System Manager. Go ahead and select the VMware node and right-click and choose Configure VMware Integration. This is a great step-by-step wizard that's going to guide you through installing the Cisco UCS Manager extensions as plugins within your vCenter implementation, defining your VMware distributed virtual switch, defining your VM port profiles, and then applying those port profiles to your virtual switch. So many of the steps that we would need in order to give this level of integration are handled right here easily by kicking off this particular wizard. So it's simple to provision that integration between the Cisco UCS Manager and the vCenter server. Once you do that, you know your distributed virtual switch is created and available. But to use the Cisco VM FEX solution, we need a service profile that's used to prepare our VMware host and that will use specific components. Remember, one of the components that's going to be needed is dynamic virtual NICs to be created in that Cisco VIC hardware. So the first component is the dynamic virtual NIC connection policy. The policy defines the connectivity between VM network adapters and our dynamic virtual NICs. The dynamic virtual NIC connection policy is a required component, and it defines the Ethernet adapter policy and the number of dynamic virtual NICs that will be created. Now, the number of dynamic virtual NICs that can be created is going to depend on the hardware that's used and the number of uplinks we have between our I/O module and our fabric interconnect. Where do we go for our dynamic VNIC connection policy in the interface? Well, it makes sense that we would slide over to our LAN tab. And sure enough, we have a policies area on this tab, and there is our dynamic VNIC connection policies. We can right-click this particular node, and we can choose Create Dynamic VNIC Connection Policy, and once again, step through this wizard. Now, this is very simple to do, and a frequent mishap is you create this dynamic VNIC connection policy and you forget to associate it with a service profile. So be sure that you are going into your service profile and you're associating this dynamic VNIC connection policy properly, or you will have problems. Another thing that you're going to want to do is you're going to want to create a VMware specific BIOS policy. Yeah, you want to make sure the BIOS settings are going to enable this VMware and Cisco FEX configuration to work just fine. So what you would do is you'd go under the Servers tab, you'd look for your BIOS policies node. And there it is. We can right click and we can create BIOS policy, and we can go through and ensure that the policy that we are putting in place for the BIOS is going to accommodate this particular set of technologies that we are working with. Let me give you a quick example here of some settings that are going to be required, and I'll just write them on screen as opposed to trying to find them in these 9 steps of the wizard, right? So let me grab my pen. Gosh, you gotta love our teaching technology here. So notice there's the BIOS processor, and what we're looking for here is to enable the virtualization technology setting. And we are going to enable direct cache access. Then under the Intel directed I/O area, there's 5 settings that we want to enable under there. We want VT for directed I/O. We want interrupt remap. We want coherency support, ATS support, and finally, we want pass-through DMA support. So, not too bad, but a BIOS policy is required that contains 2 settings under BIOS processor and then 5 settings under Intel directed I/O. Again, a common problem here is creating this BIOS policy, but then forgetting to associate it with your service profile where you're going to take advantage of FEX. So here we have a look at the Cisco UCS side of the configuration, right? We are focusing on what we would do in the UCS system to enable Cisco FEX. Quite a bit to it, quite a bit to the theory. Let's see how this would be presented in a certification exam environment. Here we are at final exam time, and this was one of our longest nuggets in the entire course. This is a nugget you may want to watch several times over. This is a nugget where in the exam environment, you would find the most number of questions. Yeah, and I tried to think of what's the worst type of question they could ask, right? So many of them will be easy, like, you know, when you're doing VMFX pass-through, what device does the switching? Something like that. And you're going to know, oh my goodness, that's the fabric interconnect that's actually doing the switching in hardware. Pretty cool. So what would be ugly would be some kind of like documentation-based question like this one. Which BIOS setting would you create in a policy for VMFX in pass-through mode? Oh my goodness. Remember we had those, I think it was about 7 different settings in 2 different areas that we had to equip in order to make sure VMware FEX in pass-through mode functions. Processor C state, VT for directed I/O, execute disabled bit, or ACPI10 support. Guess what? or IO support, that is. Guess what? It's B. Yeah, directed IO kind of gave it away, right? Because we know VMware themselves refer to that as a directed IO type of technology. So even with a nitpicky question like this, you should be able to arrive at the correct answer just using common sense in the terminology that we are dealing with. So, what a great conclusion to our DCUCI Nugget course here at cbtnuggets.com, right? This is where a bunch of technologies come together to give amazing virtualized performance to servers in our overall UCS system. The next course that we're going to present to you in this same CCNP data center field is going to leverage this one. We are going to discuss the many things that could go wrong when you are utilizing technologies like this. Technologies that are this sophisticated, that have this many moving parts. So I hope you will join me for the DCUCT course where we will examine troubleshooting a unified computing system environment. Well, I sure hope this particular nugget has been informative for you, and I'd like to thank you for viewing.